All right. So today, what we got to start talking about is taking those parent functions that you guys learned about a few days ago, and now we're going to start transforming them. Okay. So this is something you've done in the past, but um, if I was going to pick one thing that you just mastered for this first semester, it would be transforming these functions. Okay, I think something that you guys found in the first chapter was it's difficult to answer questions like domain and range if you don't even have any idea what the graph looks like. Okay, so if you can really master this chapter, the rest of the year just kind of flows so much easier because you already have an idea of what every graph that you're given is going to look like without even pulling out a calculator. Okay, so today we're going to talk about two main types of transformations. So we're going to talk about horizontal and vertical shifts. Okay, so we're going to be taking our graphs, our parent functions, and we're going to be shifting them horizontal, so left and right, and vertical up and down. Okay, so let's look at an example to start with. Okay, so here's a parent function. So hopefully you recognize that this is our parent function x squared. And then I'm going to draw a new function. Okay, so here's my new function. So I'm going to label these my parent function. I'm going to call him f of x. And my new transformed function, I'm going to call him g of x. All right, so if you look at this graph, hopefully you can kind of see what's going on here. We took our parent function, f of x, and we shifted him up 2. Okay, so it's the same graph, except we moved it up 2. So I want to talk about what would I do to write the equation of my new function. So what did we change here? So if what we did is we just took all of these points and we just moved them up 2. Okay, so this is a vertical change. So am I mainly changing the inputs or am I changing the outputs? So take a second and pause. Okay, so mainly I'm changing the output values, right? Like the input 0, the input 0, all I did is I just changed the outputs by 2. So I took the outputs and I added 2. So I'm going to write that down. So I took the outputs, which was f of x, and I added 2. That's what I did to that. And then what did I end up with when I did that? I took f of x, the outputs here, and I added 2, I ended up with this black curve, which is g of x. Okay, so which is my new graph. So I started with f of x, I added 2 to the outputs, and then I created this new graph, g of x. Okay, and so if you notice, this plus 2 is outside of the function. So it's not inside next to the x, it's out in front of the entire function. So a vertical shift, we're going to be adding or subtracting to the entire function. Okay, so I want you to take a second, I want you to think about what is going to be this new equation for g of x. So what do we think? Well, what was f of x? F of x was this parabola here, and hopefully we're getting the hang of our parent functions. That was x squared. So f of x is equal to x squared, and then we said we add 2, and then we get our new function, g of x. And so this is my new equation for g of x. So g of x is x squared plus 2. Okay? And that'll hold true for any parent function. If you want to shift that function up or down, all you're going to do is take your parent function and just add a value onto the back. If I want to go up, I'll add. If I want to go down, I'll subtract. All right, so that's our vertical shift. And we'll kind of summarize that here in a little bit. All right, so let's talk about horizontal shifts. So I'm going to start with another example here. So I'll try to keep my colors consistent. So let's stick with our parent function x squared. So f of x is x squared. That's our parent function still. And now this time I'm going to shift it horizontally. Let's go to the right 2 units. So this new graph, this is g of x. Okay? So ultimately, I want to see if I can come up with an equation for g of x. So what did I do here? So I took all of these values and I moved them to the right 2 units. So was this more of a horizontal or vertical change? Well, this is a horizontal change. So am I mainly impacting the inputs or the outputs? Well, I'm impacting the inputs, right? How do I know that? Well, one way we can think about this is, did I change the domain or the range? Well, up here, I definitely changed the range, right? It used to be 0 to infinity, then it became 2 to infinity. Here, I didn't change the range at all. So this is a horizontal change. We're impacting our inputs, okay? So if we kind of follow the same strategy as we did earlier, now we're taking f of x, but we're changing the inputs. Okay, so it's going to be f of x, and then I'm not going to tell you which yet, but it's either going to be +2 or it's going to be a -2. So we'll make a decision here in a second. So if you want to leave that blank, you can. But which one is it going to be? Well, our instincts tell us if we move it to the right 2 units, then that would be a +2. That's what our instincts tell us. But in fact, if we want to move a graph to the right, we actually need to subtract 2. It actually needs to be f of x minus 2. Now, that's all sorts of goofy, so I'm going to try to explain to you why that's the way it is. So in order to see that, let's look at this point here. So this point on my g graph, that'd be g of 2, right? So this point right here is g of 2. Now, what is g of 2? G of 2 is 0, right? So think about that for a second. G of 2 is 0, and I'm comparing that to f of something minus 2, right? So I need to know what to plug in for x here. Well, hopefully it's going to be 2, right, according to what we said. So if I plug in 2 for x, so plug in 2 for x here, plug in 2 for x there, what happens here? We get f of 2 minus 2, which is 0. So is f of 0 equal to g of 2? Well, let's look. F of 0 is 0. G of 2 is 0. And so this holds true when we did our subtraction there. Now, let's say we followed our instincts and we did f of x plus 2. All right, so let's see what would have happened here. So again, let's focus on the g of 2, which we know is 0. And if we plugged in 2 for x here, we would have to plug in 2 for x there. So 2 plus 2 would be 4. Well, where is f of 4? Well, f of 4, that's going to be all the way up here somewhere. 1, 2, 3, 4. On this blue graph, that'd be way up there. So this is not true at all. Okay? So horizontal is a little bit goofier because it's a little bit counterintuitive. But if we want to go to the right, then we have to do x minus a number. If we want to go to the left, then we're going to have to do f of x plus a number. Okay? Let me clean up my... Okay. So now we need to come up with our equation for g of x. So if you think about what we're doing here, we're saying take x minus 2, and we're going to plug that into the original f function. So this is kind of going back to the composition of functions, where we're taking x minus 2, that expression, and we're plugging it into our f of x equation. So what is our f of x equation? Well, remember, f of x is equal to x squared. Okay, remember that's our parent function, this blue graph here. So I'm going to take this x minus 2, and I'm going to plug it in right there for x. And so what we get is x minus 2 quantity squared is equal to g of x. All right, so if I want to do a horizontal change, I'm going to take my minus 2 or my plus 2, depending on the transformation, and I'm going to jam it right next to the x. So it's going to be, I'm taking this whole expression, I'm plugging in for x. Okay. The counter to that would be if I wanted to do a vertical change. Remember, I took that +2 and I put it out in front. Okay, so if it's out in front, addition or subtraction, that's a vertical change. If it's inside next to the inputs, that's going to be a horizontal change. Okay, so let's kind of sum this up for a second. So we're going to expand on this for the next few days. So g of x, I'll try to be consistent. So g of x is our new function. So what did we do here? We did f of x minus some number. I'm going to use the letter C for this one. And then if we have a number out in front, we'll just use D for now. So let's go ahead and define what do C and D do to my function. Okay, so if I have a minus C, C would be what? C would be a horizontal shift to the right. Okay, it's inside, it's next to the inputs, and it's subtraction, so we're going to shift to the right. And then what about D? So D would be a vertical shift up. Okay, so if we're adding, we're going to go up. If it was a minus D, then we'd be going down. All right, so there's our summary. So now let's try some examples here. So I want to go ahead and I'm going to give you a graph, and I'm going to ask you to write the equation for me. Okay, so here's my graph. I want you to tell me the equation. So when we do this, we have a few steps that we have to think about in our head. Step number one is we always have to ask who is our parent function. So that's the first thing you have to do, is figure out who's your parent function. Second thing is identify your transformations. Identify transformations. And then we'll combine into our equation. Combine parent function with our equation. Okay, so step one, who's our parent function? So my parent function is square root of x. Okay, so we just got to start being able to identify those. So parent function is the square root of x. Step two, what's my transformation? Well, if you know your parent function is square root of x, usually it starts at the origin. Now it's starting here at 3. So we went a vertical shift up 3. Okay, and then the last thing is combine those. So just kind of like what we did with our x squared function, now we need to come up with our new equation. So if I need to go shift up 3, then what is that going to do to my equation? So if you remember, we take our parent function and then we put the +3 on the outside because that tells me it's a vertical shift up. So this would be my equation for that graph there. Okay. So I want you to write an equation for this. So step one, identify the parent function. So this is the absolute value of x. Okay, it's our v function. Step two, transformations. I went left 2, up 1. Because usually my v hits at the origin. Now it's left 2, up 1. And then put it all together. So my new function, so horizontal change left 2, that means I'm going to add 2 inside next to the input, and up 1 means I'm going to add 1 out. So there would be my equation. Okay, more examples